is projectiles. So the objectives of this section are applying kinematics equations to moving objects, applying the independence of horizontal and vertical motion to objects moving freely under gravity. In the previous lesson, you learned the kinematics equations. There were 4 to 5 equations, actually 4 equations that you needed to know. And in M1, you have the fifth equation, which is S equals Vt minus half at squared. Then apply independence of horizontal and vertical motion, where you will have to resolve vectors in the horizontal and vertical directions. Then combine horizontal and vertical motion to calculate the movement of projectile. So we need to get the resultant velocity. We will learn this. Okay, so over here you may have to use the Pythagoras theorem, and you may have to use trigonometry to find the direction. To find the resultant, you can use Pythagoras theorem. All right, let's first thing is we have to understand what a projectile is. Objects thrown or fired through the air generally follow projectile motion. So the object that is thrown is actually a projectile, and they follow projectile motion. The path taken by the projectile is called the trajectory, and the time the projectile is in the air is called the time of flight. To do these calculations, we have to use the SWAT equations, those 4 equations that we learned in the previous lesson. Okay, so here is one of those 4 equations. Now in this example, this is considered to be a horizontal throw, meaning the projectile is initially projected horizontally. So it's like throwing it sideways. You don't throw it at an angle, you throw it horizontally. That is what we mean by horizontal throw. So it's not thrown at an angle to the horizontal, it is actually thrown horizontally. Okay, so let's go through this example. In the example of figure A stone is kicked horizontally off a cliff with a velocity of 8.2 meters per second. How much high is the stone in flight? How far does it get away from the cliff by the time it lands? The horizontal distance that the projectile travels is called the range. You have to be familiar with these terms. Even in M1 you would have learned them. The range, what a projectile is, what trajectory is, what time of flight is. Okay, I already told what these are just a while ago. Okay, so the initial velocity is 8.2 meters per second, and it is in the horizontal direction. How much time is the stone in flight? How much time is the stone in flight? So we need to find the time of flight, and how far does it get away from the cliff by the time it lands, means we have to find the range, the horizontal distance it traveled. Okay, and you can see here horizontal and vertical motions are totally independent. Okay, the horizontal motion is constant. You have to remember that the horizontal motion is constant because there is no force in the horizontal direction. Once this projectile is thrown, it doesn't matter whether it's thrown at an angle to the horizontal or horizontally, or even at an angle. So always the horizontal component of motion is constant because there is no force in the horizontal direction. The only force.
So, but the kick force.
No, that when the ball is kicked, the force acts only at the moment the ball is kicked. That means the moment that the foot is in contact with the ball. After losing contact, that force is not there anymore. Okay, so after losing contact, there is no force here. So the contact force is not there because there is no contact. For there have to be a normal contact force or normal reaction force, also called the contact force or reaction force. There has to be contact. If there is no contact, then there is no normal contact force. Okay, so what happens is we assume there is, if there is no air resistance here, then when the ball is when the object is, or the projectile is in the air, there is no force in the horizontal direction because the only force acting on the ball is its weight. Okay, once
so if there is no horizontal force, like how can it move sideways?
Okay,
it moves a certain distance, right?
Yeah, it was directed in that direction. So for example, okay, you can think of example like this. A car is moving horizontally. Okay, and we assume there is no air resistance. In most of your calculations there is no air resistance. If the car is moving horizontally and if the driver takes off his foot from the accelerator, then what happens? There is friction between the tires and the ground, and this slows down the vehicle. Okay, so there is a force of friction which is opposite to the direction in which the object is moving. If the resultant force is opposite to the direction of motion, the object will decelerate. If there is no force in the direction the object is moving, then according to Newton's first law, the object will move at constant velocity. Okay, so there is no change in the velocity in that direction, or we can say there is no change in speed. The magnitude of velocity is speed. So once the ball is kicked, now initially it was kicked in this direction. Okay, so that's why it goes in that direction. But what happens is, after losing contact, the only force acting on this ball, assuming there is no air resistance, the only force is the weight, which is acting vertically downwards. Okay. So what happens is, there is no other force in any other direction. The only force is the weight, which is vertically downwards. That's why this ball gets pulled down. Now if there was no weight force or no force vertically downwards, it wouldn't follow this path. It would follow some other path. It would follow a path where the force is in. So if there is a force, the object will tend to move in that direction because it will accelerate in that direction. It doesn't need to move in that direction, it will tend to move. Okay, the word I use is tend to move. So an object doesn't need to necessarily move in the direction in which the force is acting. Previously I gave you the example of the car. Okay, the car is moving forward, but the resultant force on the car is backwards. This causes the car to slow down, and if it was long enough, it will slow down and stop. Okay, but if this force was still acting even after it stopped, then what will happen? It will move in the reverse direction. This is what happens when you throw a ball up in the air. When you throw a ball up in the air, assuming there is no air resistance, what happens is, now the only force acting on the ball is its weight. Okay, so the ball is going up, the weight force is down. So when the ball is going up, it decelerates, and then it comes to a stop at the highest point. Then what happens? It falls back down. When it falls back down, the resultant force and the direction the ball is moving is in the same direction, so it will accelerate. If the resultant force and the direction of motion are in the same direction, the object will accelerate. If the resultant force and the direction of motion are in opposite directions, the object will decelerate. Okay, yes. So let's look at this example here. Now if you have a projectile like this, the only force acting on this is its weight. So there is no force in the horizontal or any other direction. The only force is in the vertical direction. So that means there is no acceleration in the horizontal direction because there is no force in the horizontal direction. So there is no acceleration in the horizontal direction, but the force or weight is in the vertical direction. So there will be an acceleration in the vertical direction. Okay, now if you want, we can draw a free body force diagram. Previously I told you what a free body force diagram is. It's a diagram showing the only forces acting on the particular object. So if you consider this one, there is a weight force which is acting vertically downwards. Okay, so this is the free body force diagram, because we assume there is no air resistance, so only force is this. So this is the free body force diagram. Now according to Newton's second law, F is equal to ma equation, the resultant force and the direction of motion are in the same direction. We have F equals ma. This force is a vector, acceleration is also a vector, and according to Newton's law, we know the acceleration and the resultant force are in the same direction, and it is the resultant force which produces this acceleration. Okay, so for an object that is which is actually a projectile, the only force acting is the weight, which means now what this weight causes is the acceleration due to free fall. So the acceleration is again vertically downwards, and that acceleration, which is what we call the acceleration of free fall g. So a equals g. So from this we can also write the equation W equals mg. Okay, So in questions like this, we resolve the initial velocity in two directions. Now this projectile is projected horizontally. Okay, so there will be some questions where it is projected at an angle. Okay, so the initial velocity they have given us is v, or rather we can call it u. Okay, we can use u. Now u is actually ux, because it was sent in the horizontal direction. Now when it is projected in the horizontal direction, there is no vertical component of motion. So what we can say is uy, component of velocity in the vertical direction, uy equals 0, because it was projected horizontally. So the initial vertical velocity is 0. Okay, we can also say the acceleration in the horizontal direction is 0, because there is no force in the horizontal direction. And if you take the component of weight and resolve it in the horizontal direction, this will be cosine 90. So w cosine 90 is 0, because cosine 90 is 0. So there is no acceleration in the horizontal direction, but there is an acceleration in the vertical direction, which is equal to g, or 9.81 meters per second squared. Okay, these are the two important things that you need to understand. For a projectile, if it is horizontal, if it is projected horizontally, the initial vertical velocity is 0. Remember, if it is projected horizontally only, the initial vertical velocity is 0. And for any projectile, whether it's projected at an angle or horizontally, the ux, that is the horizontal velocity, is constant, meaning because the acceleration is 0 in the horizontal direction. And for any projectile, the acceleration vertically downwards is the acceleration due to free fall, because it is
so at the initial state it doesn't have an acceleration horizontal.
No, not only the initial state, throughout its motion it doesn't have an acceleration in the horizontal direction, because there is no force in the horizontal direction.
So I didn't still get it why it takes that path, sir, like travels a bit far.
Yeah, because it was initially directed in that direction. So the initial force that was exerted was in this direction. So that's what causes it to go in that direction. For example, let's say you push something. So in the beginning it will move in the direction you have pushed it. But afterwards what happened? Because there are other forces. Now example here, there is the weight force is there. So that will try to prevent it moving in the direction which you directed it, and it will cause the object to move in the direction which it is that force is acting on. So in the beginning you applied this force which caused it to go in that direction, but afterwards what happens? The weight force is the only force that is now there. So instead of making it continue to go that way, the weight force will pull it downwards. Okay, if it was going long enough, then finally its final motion will be completely vertical. Like for example here, can you see here? So initially you applied the force in that direction, it's going in that direction now, but because the weight force is there, it will pull it down, because this force is now not there anymore. If this force was there, and if the weight force was there, then there will be a resultant force, and the object will move in the direction of that resultant force of the weight force and the force that you continue to apply, if you continue to apply it. Is that clear?
So that means the weight is reducing the horizontal force.
Vertical force. Weight is acting vertically.
Yeah, vertical. So the weight is reducing the horizontal force.
It is reducing the effect of the horizontal force, you can say.
Yeah, the effect.
Yes.
So, sir, at that curve, there is a horizontal force present.
No, I told you before. The only force that is acting after it leaves the foot or after it leaves the cliff is the weight force. Okay, so in the beginning when he kicked it, this force was acting in that direction. So immediately it can't go down, because when he kicked it, that force caused it to go in that direction. Now after the ball leaves the foot, the only force that is acting on the ball is the weight. So instead of making it continue to go in that direction, it will make it pull it downwards. Okay.
Okay.
Is that clear?
So this
But
is
if the weight force was
Newton
not
first
there,
law.
if there was no other force after he kicked it, then it will continue to go straight in that direction, in the horizontal direction. Is that clear?
Yeah. So this is Newton's first
Yes,
law, sir.
first law, yeah. Because if once he kicked it and if there was no other force, then it will continue to move in the original direction that it was kicked. Newton's first law, yes. Okay.
Yes, sir.
Okay, then now we will have to use that knowledge to do this. The initial horizontal velocity is 8.2 meters per second. Okay, so we can also write it here if you want. Initial horizontal velocity. We know this ux. Okay, since I don't have space there, I will write it here. The initial horizontal velocity x, because it's in the x-axis direction, is equal to 8.2 meters per second. Okay, now what we are supposed to find here is how much time is the stone in flight and how far does it get away from the cliff by the time. So to find the time, we can consider the vertical motion. Okay, so we know the initial vertical velocity. Now we don't need the horizontal component to determine the time. Okay, since they have done it here, I will explain this part. So in the initial, now we are using this equation which we learned in the previous class. S is equal to ut plus half at square. Now the acceleration, now we are applying this in the vertical direction. So when we apply this in the vertical direction, we can take downwards as positive. So anything in the downward direction will be positive. Now the initial vertical velocity is 0. So this this term is 0. Okay, that's why they have not written it there. You see here u is 0. So therefore ut is 0. So therefore the first term is 0. Then you get half at squared. Then we can make t the subject of the equation. Then this will become 2s over a. T equals 2s over a. Now since we are applying this in the vertical direction, they have given us the vertical height through which it falls, which is 60 meters. Okay, so we can substitute 60. Okay, by the way, why they are using minus 60 here is because they take up as positive. If you take down as positive, then this will be plus 60. It depends on you. If you want, you can take up as positive, then everything down will be negative. If you take down as positive, everything up will be negative. Now here they have taken up as positive, so anything that is down will be negative. So s is the displacement, it is vertical, it's down, increasing downwards, so that's why it's minus 60. And so from this level down, this 60 meters is downwards, so that's why it's minus 60. And the acceleration due to free fall is also vertically downwards, so that's why it's minus 9.81. They have taken up as positive. Okay, so when you substitute this and simplify, you get 3.5 seconds. Okay, then finally to get the horizontal, now this is the time, the answer for the first part, that is the time of flight. Then how far does it get away from the cliff by the time it lands? So we have to find this. Now the time it takes for the vertical motion is the same time that it takes for the horizontal motion. Now there is no separate horizontal and vertical motion. We resolve horizontally and vertically and then do it. Okay, so we can consider the independence of the horizontal and vertical motion. So we consider each one separately. The horizontal motion, we take it one in the horizontal direction, vertically again we separate it like this and do it. So if you consider in the horizontal direction, it will be ux, which I wrote here. Okay, and I told you this is a constant velocity, and this also will be acting for the same time. So you can imagine this motion in two parts. One is in the vertical direction and the other one is in the horizontal direction. Okay, so what happens is in the horizontal direction, it takes the same time for it to go from here to here as it takes for the ball to go from here to here, because it's just one ball. It's going horizontally as well as vertically. So if you can look at the 60 meters, it takes this much time 3.5 seconds to fall down 60 meters, and also it takes the same time to travel the horizontal distance d. Is that clear?
Yes.
Okay, so we consider the horizontal motion and the vertical motion separately. Then since the horizontal velocity is constant, we can use this equation: velocity equals displacement divided by time. Okay, so we are considering this in the horizontal direction. Now we can take to the right as positive. Then d is equal to vt. V is 8.2 because the initial velocity is in the horizontal direction, so we can use this value. And then the time is again the same time here, 3.5, so we get 28.7 meters. So it travels.
Sir, how did you get 8.2, sir?
Huh?
They are given.
Yes, it's given in the question. See, 8.2. Okay, 8.2 is given here. Okay, then the next part is to find the vertical component of velocity just before it hits the ground. Now you can see here, this is just before it hits the ground at this point. Okay, so let's assume it is moving at an angle. Now they have shown like it is it's almost vertical is what they have shown, but what we can think is it's hitting it like this. Okay, so it follows a path. We can assume it follows a path like this. So let's say this is the cliff, and then let's say this is the ground. Okay, so we assume it follows a path like that. Okay, it's a parabola. The path is called a parabola. Okay, it has to be the shape of a parabola, like a curve. Okay, so it has to be, I'll use a different color. It has to be a path like that. Okay, so you can see just before it hits the ground, it has a horizontal component of velocity and a vertical component of velocity, and it hits at this angle like that. Okay, so actually its actual velocity is this velocity here. We can call it v. It's actually this velocity here, v. This arrow. Okay, now we can the longest arrow here, that is the resultant velocity. Okay, so we have here vx, and this way we have vy, and this is v. Okay, the longest arrow is v. What we can do is to find this, first we can find vy. Okay, again we can use v squared equals u squared plus 2ax to find v, because we have the initial velocity. Now this is in the vertical direction that we are doing. Okay, again they have taken up as positive, so anything down will be negative. Okay, initial vertical velocity is 0, so that's why this is 0. Then 2as. 2a is what? Minus 9.81, again because they took up as positive. And then s is the vertical displacement, that is minus 60. Again y minus, because they have taken up as positive. Then you get this. And then you can get the final vertical velocity. This is the component of the velocity in the vertical direction, vy, just before it hits the ground. Okay, so that is minus 34.3 because we take up as positive, this is down. Then we can use Pythagoras theorem to find the resultant velocity, which is this velocity v here. So this we can find using this equation here. And then once you know that, this you already know. So it is the same throughout the motion. Okay, it is 8.2. So we use that 8.2 and 34.3, which we found here, and then that will give us 35.3, which is the actual velocity, the resultant of these two, vx and vy. So this is the velocity that it will hit the ground here. Okay, that is 35.3, and the angle can be found using trigonometry. The angle at which the stone is flying on impact with the beach. Okay, so that is actually this angle they are finding. Now again, if you use tangent, you can find the angle. Now you know this angle here is the angle that it makes with the horizontal or the beach. Okay, so that is that angle here. Okay, and you know this angle here is equal to this one because they are alternate angles. These
so
two.
why are we calculating horizontal and vertical velocity separately?
Because you want to find the actual velocity v here. You can't directly find it because this is thrown at an angle. If it was dropped vertically, then you can directly find it using the equation. But since this is moving at an angle, we have to do it in parts like this.
Okay.
Okay. All right. So then we get this value. Okay. So we are using tan. So this side is having a length. This side is Vy. So this side also is Vy. Now if you know this side, we can use tan. Let's say this angle is theta. If this angle is theta, then we can say tan theta is equal to opposite side. So we consider this triangle here. Tan theta is equal to opposite, which is Vy, divided by adjacent Vx. Alright, so the opposite side is 34.3, which is Vy, the vertical component of velocity. So this is 34.3 in magnitude, and then Vx is what they said in the question, 8.2. So it will be 34.3 divided by 8.2. So the vertical component of velocity divided by the horizontal component, and then take arctan of that or shift tan of that in your calculator. Then it will give 77 degrees. If you want your answer in degrees, your calculator should be in degree mode. If your calculator is in radian mode, you will get this angle in radians, but we want it in degrees for physics. Okay, so the stone's velocity when it lands on the beach is 35.3 meters per second at an angle of 77 degrees down from the horizontal. Okay, so down from the horizontal. Okay, so that is what they are actually meaning is this one, down from the horizontal. This is the horizontal, down from the horizontal. Also we can say it this way in terms of this the way this is, but because the vector is this way, the direction is this way, so they say down from the horizontal because the arrow is pointing this way, the velocity is in this direction, so down from the horizontal this much. Okay, then if it was a vertical throw, okay, so here it is thrown at an angle. Okay, when it is thrown at an angle, it will reach a highest point. Let's say somewhere there, it will reach a highest point, and when it is at the highest point, the vertical velocity here is 0, but the horizontal component of velocity throughout the motion is the same. The horizontal velocity is throughout the motion the same, the horizontal component rather, but the vertical component of velocity at the highest point is 0. So you can see in the vertical direction at the highest point it's not moving in the vertical direction, so it's 0. But throughout the horizontal motion, the horizontal component of velocity is the same.
Constant.
Yes, because there is no force, no acceleration in the horizontal direction. No acceleration because there is no resultant force in the horizontal direction. We assume there is no air resistance. If there was air resistance, yes, then the velocity in the horizontal direction will decrease because it's moving.
Sir, then why does it take a curved path, sir?
Because it is thrown at an angle. Like I said before, now this person is throwing it this way. So he's throwing it this way and he's throwing up, right? So he's throwing it this way. Now what happens is the weight force is vertically downwards. So it's trying to pull it down. Do you get it? So since it was thrown this way, the weight force is the only force acting now. So it will try to pull down. So because it's going up, then it's trying to pull it down. So it comes up to this point and now it is coming down. If you throw it faster, then it will go higher. Okay, the weight force has to do more work to bring it down. Or rather you have to do more work to throw it up. Okay, so they are asking here, a ball is thrown with a vertical velocity component of 5.5 meters per second. How much time is it in flight? How high does it get? Again asking you the time of flight and the how high it gets. So the vertical height. Okay, so what we know is we know at the highest point the the velocity at the vertical velocity at the highest point is 0, and they have also given us a ball is thrown with a vertical velocity of 5.5 meters per second. How much time is it in flight? How high does it get? Okay, so you can assume it's in the vertical direction. So initial vertical velocity is 5.5. Okay, so considering only the vertical component of velocity, so they have not actually told us the horizontal component of velocity or the actual velocity with which it is thrown. They only give us the vertical component of velocity. Okay, so we know the vertical component of velocity Vy, and that is this, and also that is when at the time it is thrown. Then at the highest point it is 0. Okay, what else we know is the acceleration of free fall, which is vertically downwards 9.81. Okay, so what we are supposed to find is the time and how high it gets. So based on the information we have, we can draw a diagram and label all the quantities, because that will make it much easier for you to understand and then figure out which equation you are supposed to use. So what we have is we are given only the vertical component of velocity. Vy is equal to, sorry, we call it Uy because it's the initial vertical velocity. Vy will use for final one. So Uy is equal to 5.5 meters per second. Then now what happens is at the highest point, okay, so let's say it takes a path like this. It was, you can assume it was thrown at an angle, but we are concerned only about the vertical component of velocity. So at the highest point, the vertical component of velocity Vy equals 0. So Uy equals this, Vy equals 0. Now what else we know is that the acceleration of free fall G is equal to 9.81, and that is vertically downwards, meters per second squared, and we are supposed to find how much time is it in flight. So first what we can do is we can find the time it takes to go up, and it takes the same time to come down. The time it takes to go up is the same time it takes to come down. Therefore we can find the time it takes to go up and multiply it by 2. Okay, so we'll say we are supposed to find t. Okay, now the equation that has all these quantities is v equals u plus at. Okay, so we can use v equals u plus at, and v is 0. Now again the direction is important, so what we'll do is we'll take up as positive. So v is 0, u is 5.5 meters per second, plus, now a is here negative because we take up as positive, a is vertically downwards, so it's 9.81, and t. Okay, now you can use your calculator. Okay, by the way, sorry, this should be negative because that is up, so minus 5. G is down. The acceleration is acceleration of free fall, that is vertically downward, so that's why it's negative. We took up as positive, so we move this to this side, it will be minus 5.5, and then divided by minus, we divide both sides by minus 9.81, so the negative signs cancel out, and you can use your calculator and figure out the answer. It will be 5.5 divided by 9.81, which will give you 0.56 seconds.
Yes.
But this is not the final answer. This is the time it takes to go up. Now it takes the same time to come down. So we can say it takes same time to fall back down, to fall down. Therefore,
multiply.
yeah, total time is this times 2. 0.56 times 2, which is equal to
1.12.
yeah 1.1 seconds. And you also have to write the unit, because you can get marks for the unit also. If you don't write the unit, you may not get full marks. Okay, let's see what they have done. Okay, so can you see here 0.56, so the overall time of flight will be 0.56 seconds, double. Total will be 1.12. They have given it to 3 significant figures. Okay, then how high does it get? How high does it get is the next part. Now to do that, again, the best thing is that we have drawn this diagram, and then we can label the other quantity which we are supposed to find, which is how high. So that is SY. SY means the displacement in the vertical direction. This is what we are supposed to find, SY. Okay, so again we can see which equation has this, and this, these 4 quantities. The equation that has all those quantities is S is equal to ut plus half at squared. Oh no, but we don't have t, right? T, we can use this, but if we use this, what happens is we will have to use this value. So instead of using this, we will try to use an equation that doesn't have t but has all the other quantities which we have here. So that is what? V squared equals u squared plus 2as. V squared equals u squared plus 2as. Now V at the highest point, so again we can take up as positive. So whatever down will then be negative. So up as positive. V will final velocity will be 0. Okay. Then initial vertical velocity is what? 5.5. They have given us that. So we are applying this only in the vertical direction. Okay. So all of this will be what? Vy, uy, ay, sy, all in the vertical direction. So initial vertical velocity is in the vertical direction. So we take, because we take up as positive, this will also be positive. Then plus 2 times a is minus 9.81 because it is vertically downwards. Okay. So 9.81 times this is what we need to find, sy. So what we can do is we can square this and move this to the other side, then it will become negative, and divide it by this. Okay, again you can use your calculator. 5.5 square divided by 2 times 9.81, that will give us 1.54 or 1.5 also you can say. So sy is equal to 1.5 meters. Yeah, see 1.5 or 1.54 meters. You can write 1.54 and then round off to 1.5 if you want, but in these questions they don't really look for the significant figures. So they usually give it to 3 significant figures. Okay, then you can answer all these questions, and these definitions are important. A projectile is a moving object on which the only force of significance acting is gravity. The trajectory is thus predetermined by its initial velocity. So a projectile is, like I said, something that is thrown, because once an object is thrown, the only force of significance acting is gravity. So the only force is gravity, assuming there is no air resistance. The trajectory is thus predetermined by its initial velocity. Now this was what you asked me. The trajectory is the path taken by the projectile. So it is predetermined by the initial velocity. So it is determined by the direction you initially throw it. So the initial vertical velocity, initial velocity is in the direction which you throw it. Okay, so that's how that direction is predetermined. Then what happens is the weight force tries to pull it vertically downwards and prevent it trying to go there in the original direction which you threw it. There are more questions here. Okay, we can also go through this here. Okay, if you look at this one, worked example, a stone is thrown horizontally with a velocity of 12 meters per second from the top of a vertical cliff. This is very similar to the question you did. Calculate how long the stone takes to reach the ground 40 meters below and how far the stone lands from the base of the cliff. So it's a very similar question. Okay, first thing is asking how long or the time for it to fall vertically downwards. Now again, if you want, you can draw a diagram for this kind of question. Alright, so draw the diagram or sketch a diagram and then label all the quantities that are given. So let's say this is the cliff here, and then we have the stone. We can model them as particles, meaning small circles like this. The objects can be modeled as particles or small circles like this. Okay, so it is projected horizontally. So we have ux is the initial initial velocity, and that is 12 meters per second. Okay, 12 meters per second from the top of a vertical cliff. Now what happens is, because it is projected horizontally, the initial vertical velocity uy is 0. Okay, this is very similar to the first question we did. Uy, or the initial vertical velocity, is 0, and we are supposed to find how long it takes. Okay, so the time it takes to go from here to the ground, let's call it t. Okay, so ground 40 meters below, so this time, and also we can label s in the y direction is 40 meters, and how far the stone lands from the base of the cliff. So we are supposed to find sx also. Okay, so let's say this is the path the projectile takes. Let's say it has to be a parabola. Okay, parabolic path or parabola. So in this one we can label from here to where it hits the ground sx. We need to find this also. So there are two quantities that we need to find, t and sx. So again, very similar to the previous question, same equations can be used. Now since they have done it here, I'll explain this one. Now what they are doing is, here, unlike the question that you did, here they assume downwards as positive. Okay, so we assume downward as positive, so arrow down, arrow positive, and this is then sy, uy, ty, t half a by t square, because all are in the vertical direction or y direction. We take downward as positive. Now this is 40 because that is the downward displacement, 40 meters. U is the initial velocity in the vertical direction, that is 0. Then half a is again vertically downwards, and since we took down as positive, that is 9.81, positive 9.81, and then t. So solve for t and you get 2.86 seconds. Now that is the time it took to go from here to here, but we considered vertical motion separately here. Then we are supposed to find this also. Now if you consider the horizontal motion, again the time it takes to go horizontally, that is from here to here, is the same time it takes to go in the vertical direction from here to here, because it's following this path. Then the time for this motion is also the same, so we can use this 2.86 and consider the horizontal component of velocity, which is 12, and then do it. So what we can use is, again we can use s is equal to ut plus half a t square, and in the horizontal direction, but since there is no acceleration in the horizontal direction, this term becomes 0. So we get s equals ut, sx, okay, sx equals uxt. Then ux is 12 and the time is the same time, so it is 2.86, and then we get 34.3 meters. So sx is 34.3.
Okay, sir.
Okay, so here are all the quantities that are given. Again, if you look at the diagram, you can see that. You may find it easier to summarize the information like this: vertically, S, so in the vertical direction and in the horizontal direction. So in the vertical direction, S is 40 meters, SY that is. U is 0. The initial vertical velocity UY is 0, this one. Then the vertical acceleration again is in the vertical direction. Oh, by the way, I have not shown that here. We can also show that. So in the vertical direction only we have the acceleration A, which is equal to G, that is 9.81 meters per second square. And you can see that is what they have given in this over here. Then if you consider horizontally, now all they have taken downwards, vertically downwards positive, and then they have taken horizontally to the right as also positive. And horizontally U is actually UX, so that is UX what they are referring to, that is 12. Then final velocity also over here. So in the beginning when they threw it, that is UX. Over here what we have is what? VX, just before it hits the ground. Again Vx is equal to again 12, because the horizontal velocity is unchanged. So this is equal to again Ux or U. Okay. Then in the horizontal direction the acceleration is 0. Okay, we could have also labeled that. Again in the horizontal direction, because there is no force, the acceleration in the horizontal direction is 0. That's why the velocity in the horizontal direction is constant. Alright, and then we are supposed to find time V, this V in the vertical sorry, not the V, the time, right? Yeah, the time and the displacement, but here they have said V also. If you want we can find V also, but actually if it's a horizontal component of velocity it's the same, but if it's a vertical component, again like what we did before, we can use an equation, maybe V equals U plus 80 and do it, because we know the time. So we can use V equals U plus 80. Also we can use V squared equals U squared plus 2AX. That is better, because then we don't need to depend on another answer to calculate V. If we use V squared equals U squared plus 2AX in the vertical direction, V squared equals U squared plus 2AX or AS in the vertical direction, if you take downwards as positive, then we know U, that is 0, Uy, okay, Uy, you know that is 0. Vy is what we need to find here. Then 2 into A is what? 9.81, S is 40. So you can, using that you can find the final velocity, component of velocity in the vertical direction.
Okay.
Then this question, 10th one. What? A ball is thrown.
The next is energy, right?
Yeah, we can go through this one also quickly. Now here it is thrown at an angle. You can see 20 meters per second. That question which we did earlier, it was thrown vertically. Now here it is thrown at an angle. So over here, this is, I think, the little bit more complicated one compared to the questions that you have done so far, because here we have to consider the vertical component as well as the horizontal component separately in this question. A ball is thrown with an initial velocity of 20 meters per second at an angle of 30 degrees to the horizontal. Calculate the horizontal distance traveled by the ball, its range. Now I told you before, the range is the horizontal distance traveled by the projectile. So this ball is thrown and everything is labeled here, 20 meters per second at an angle 30 degrees to the horizontal. So the horizontal is this way. Calculate the horizontal distance traveled. So we have to find this, the horizontal distance from here to here. And we also need to find, we also can label the vertical acceleration here, which is 9.81, that is vertically downwards. Okay, so let's see how this is done. Split the ball's initial velocity into horizontal and vertical components. So we can also draw a diagram. Okay, so if you separate this, okay, so we have this now in the beginning. So this is the ball, very important question. Okay, it covers a lot of content. You will be able to do the questions much easily when we cover this important question. Okay, so at an angle of 30 degrees, now we need to find, we can also, like I said, we can also label A equals G equals 9.81 meters per second square, that is vertically downwards. So what will happen is it will follow a path like that and it will hit somewhere here. Okay, but you can see the vertical height is 0. Okay, so what happens is the vertical height, once it goes and comes back, the vertical displacement is 0. This is the horizontal displacement. It has a horizontal displacement, but because it goes up and comes back to the same vertical level, the vertical displacement is 0. Okay, now we know also ux is the component of u in the horizontal direction, that is a constant, because the acceleration in the horizontal direction is 0. So we can say a is equal to 0, ax, here we can call this ay or g. Then ux is equal to 20 cosine 30. Now you can see again the vector sweeps the angle. If you consider this to be the vector, if it's sweeping the angle, if it's covering the angle, when you do it like this, then that is cosine 30. Also, that is actually easy way, or you can draw the triangle and then do it. It will take a bit longer then. Okay, and then we can also see the component in the vertical direction. So if it sweeps the angle this way, then perpendicular to that side. So it will be uy, which is uy equals 20 sine 30. 20 sine 30. Sine 30 is half. So this will be equal to 10 meters per second. So it is projected at an angle of 30 degrees, and if you take the vertical component of the initial velocity, that will be 10 meters per second. Okay, we are supposed to find the range, so that is this distance. Now to do that, what we need is, now the equation we know is what? Sx, s is equal to ut plus half at squared. So if we use Sx ut plus ux times t plus 0, why? Because there is no acceleration in the horizontal direction. So if you know the time, and you are already given ux, okay, so we found that, and multiplied by the time, we will get the displacement. But to do that, first we have to consider the vertical component of velocity, which is in this case we can consider that one, which is this one. So again we can use s is equal to ut plus half at squared, but this time we are using it in the vertical direction. I'll tell you why, because we need to find the time. So if you use it in the vertical direction, since it goes up and comes back to the same level, the displacement in the vertical direction will be 0, because it comes to the same level. And then uy is what? 10, then t is the time we need to find, plus half. Now since we took up as positive, downwards it will be minus 9.81. Then time is again what we need to find. So you have a quadratic equation here. Okay, so you can simplify this and find the time, and since they have done it, I will show you here. Again, can you see it's the same thing that we got? You see here 10t plus minus 9.81 divided by 2 is 4.905 minus 4t square. Okay, so when you divide this by 2, you get this. And then since it's a quadratic equation, there will be two values for t. One is 0 and the other is 2.04. Why 0? Because that is the time when the displacement is 0. So the displacement is 0, vertical displacement is 0 here as well as here, and here the time is 0, t equals 0. Here the time is 2.04. Then horizontal displacement, using this time we can find the horizontal displacement by using this equation. By using this equation, okay, so the time is the same time, so we can use this equation, and then so ut sx equals uxt, so the time is the same time, and ux is 20 cosine theta, that will be 17.3. Okay, so hence the horizontal distance traveled by the ball, which is called its range, is about 35 meters. Yeah, here they find the horizontal component of velocity, 20 cosine 30. Horizontal component of initial velocity, 20 cosine 30, which is 17.3. Okay, this value is 17.3. And that's the end of projectiles. And here is a summary of what we have done so far. In the previous lesson we learned these 4 equations. These 4 equations are extremely important. You will use them again and again in kinematics as well as accelerated motion projectiles and so on. For projectiles, the horizontal and vertical components of velocity can be treated independently. In the absence of air resistance, the horizontal component of velocity is constant, while the vertical component of velocity downwards increases at a rate of 9.81 meters per second square. So again, keep in mind the horizontal component of velocity is constant because there is no acceleration in the horizontal direction, while the vertical component of velocity downwards increases at a rate of 9.81 meters per second square because the acceleration is vertically downwards. Okay, any questions?
No.
Okay.